Find the lightest I-beam. In this problem, an I-beam is subjected to a given dead load and a given live load, which is an axial force in tension. The yield strength of the steel is provided, and the problem states to assume the I-beam will experience a yield failure. Looking ahead, we'll first observe our four choices of I-beams. We'll use I-beam W8/58 as an example. Here, the W stands for wide flange, which means this type of I-beam will have an increased section modulus, area moment of inertia, and other parameters relating to the section geometry. The first number after the W represents the depth of the beam in inches, which is the distance from the top of the top flange to the bottom of the bottom flange. And the last number represents the weight per length of the beam in pounds per foot. Therefore, the linear weight of the four possible I-beams to choose from ranges from 58 pounds per foot to 68 pounds per foot. Since we're trying to find the lightest I-beam, we'll choose the beam with the smallest linear weight, which can withstand the axial loading provided in the problem statement. Using LRFD, the maximum factored load, gamma Q, shall not exceed the design strength of the steel member, BR. The maximum factored tensile load upon the member is the maximum computed load from various load combinations. In these equations, D equals the dead load, and L equals the live load. None of the other loads are mentioned in the problem statement. Although there are 5 other load combination equations, we only have to consider the first 2 because they are the most conservative when only dead loads and live loads are provided. After plugging in these loads for D and L, the factored load equals the maximum of 840,000 pounds and 816,000 pounds, which is 840,000 pounds. The problem states to assume a yield type failure, which means the design strength equals 0.9 for phi, and the resistance term, R, equals the yield strength of the steel, Fy, times the gross area of the steel beam, A gross. From the problem statement, we know the yield stress of the steel equals 50,000 pounds per square inch. Therefore, if we simplify this inequality and solve for A gross, we learn the gross area of the I-beam must be at least 18.7 inches squared. Looking back at the 4 possible solutions, we can look up the gross area of each I-beam and determine the lightest I-beam with a gross area at least 18.7 inches squared, which is beam W12/65. Therefore, the answer is C.